Hello, my name is Ryan Hullinger. I'm an architect and a partner at NBBJ. About a week and a half ago, on March 20th, a group of researchers at the National Renewable Energy Lab, NREL, asked us to provide insight on mobile ICU design based on our track record for healthcare prefabrication. This deck is our response to that request. We begin with the situation assessment, and essentially there are three critical shortages on the COVID-19 response horizon: a shortage around inpatient beds and caregivers and equipment, especially PPE and ventilators. It'd be safe to assume that an architecture and design firm could only help with that first shortage around actually providing the beds, but actually we're focused on a design response that addresses all three of these critical needs. So for the need tied to the bed shortage, we're addressing it through prefabricated, rapidly assembled turnkey strategies. The caregiver shortage is addressed through the layout of these prefabricated components, a layout that maximizes the capability of each caregiver and enables an understaffed team to support as many patients as possible. And in terms of equipment, we're also working up that layout in a way that enables multi-patient sharing of life support equipment and reduces the consumption of PPE. All the work we're presenting in this deck builds on the excellent work that's already been developed by the U.S. Army Corps of Engineers, specifically their arena to healthcare approach. This approach allows them to take over a stadium, a field, a convention center, and turn it into a dedicated pandemic response unit, in each case using an existing building shell. The dedicated unit that's built inside of that shell has a lot of advantages in terms of speed, bed capacity, caregiver efficiency, and the ability for equipment sharing. In a dedicated facility like this, every patient is pre-screened positive, and therefore patients don't need to be isolated from other patients. In this environment, with the exception of switching gloves, PPE does not need to be replaced when moving from one patient to another, which vastly reduces the consumption rate for it. So now we move into the specifics around the Army Corps of Engineers A2HC approach and the way we've built on that. Here you see the way they lay that approach out on a football field. You have essentially 8 modules that are repeated across the space of the field. Each of them surrounds a nurse station with patient beds. And in this case, they're showing 5 patient beds on 3 sides of each nurse station. From here forward, we use that approach and we extend it and we think about how to optimize it for all 3 of those shortages. An important thing to say at this point is that while that approach is designed specifically for use in an arena, it is not limited to that use space. It could be used in a gym, a cleared office floor, a parking garage next to a hospital, a convention facility, or even a tent. So we take the Army Corps of Engineers template and use it as an underlay in a 3-dimensional model, and we begin to load in each of the components, starting with the prepackaged heating, ventilation, and air conditioning systems that provide air filtration to the space. Those happen at the corners of each of these care modules. Then we load in the beds, in this case, the 5-bed array that happens on 3 sides of each nurse station. The beauty of this arrangement is that the proximity of the beds enables the sharing of ventilators or other life support equipment in case of shortage. It's much easier to do that in this kind of environment than it is in a compartmentalized space that you might take over, like a hotel or a skilled nursing facility. Then we move on to the caregiver workstation. These happen in the center of each of these modules, and we're proposing for this that they be built out of readily available office systems furniture. We can do that because there's a deep existing inventory of the office systems furniture, and it can be rapidly produced and installed. What's nice about the Army Corps layout is that that nurse station has eyes on all 15 beds. So this ties into that second shortage, the nurse shortage. The nurse shortage response here maximizes the visualization capability of every available nurse. Now what we're showing in this layout is a little bit different than the Army Corps layout, which provides some tenting around each bed. What we're showing here is a freestanding privacy screen that could be moved or doubled up in between patients, but we're really working on prioritizing the caregiver visualization from that center desk out to each patient, understanding that we might not have enough nurses to provide best practice visualization. So we want to make sure that every nurse who is working in this station can have eyes on every patient. Then we move on to the fourth component, the patient support corridor. This is a really interesting space. It's a dedicated corridor for patient and equipment support. We're saying that this is the piece that can be rapidly constructed via an array of prefabricated head wall units. So that whole corridor is made of prefabricated componentry. And each of those prefabricated components is essentially a head wall. It delivers power, data, medical gases, and task lighting to the patient. A zone is created here that the care team can occupy, and they can occupy it without donning PPE, reducing that PPE consumption rate and hitting on the third shortage. And we want to even consider opportunities for moving some life support equipment from patient bedside through the head wall into this space. That way, that equipment could be accessed without being in the red zone next to the patient. Here, you see one of those head wall components. And then as we scroll forward through the deck, we see those being arrayed next to each other in order to create a wall and all 5 of the beds in that unit. If we just zoom in on one of those, the advantages here of prefabrication are the faster production and delivery. We're utilizing existing inventory and a streamlined manufacturing process. This is the same kind of head wall that's been mass produced for hospitals, so that inventory is something we can leverage. You also, with this approach, get faster installation and setup. It's a turnkey solution, a reduction in installation errors because it's simpler to install. And this last one's very interesting. We believe that it will provide improved caregiver work environment. What you're getting here is a closer ergonomic match between the steady state condition where a nurse typically works and the crisis state condition of this arena. And that should improve the caregiver work performance and also reduce errors. Then we begin to think about a new approach to the materiality for this wall that's specific to temporary construction and crisis response. So instead of what we would typically do in a permanent hospital, where this prefabricated assembly is clad in solid material like Corian, we're proposing that in this case, it's clad in something transparent like Lexan. Lexan's extremely durable, and it can be cleaned with rubbing alcohol. When this wall becomes transparent, something very interesting happens. The caregivers on the other side have a visual connection to the patients in the red zone. So essentially, you see here that transparency enables the caregiver to have additional direct visual access from the head wall side of the bed. And we're creating something interesting. Fundamentally, it's an interstitial head wall. The head wall is transformed from planar to volumetric. And this improves patient visualization, improves caregiver protection, and ease of access to life support equipment. Next, we think about how these units are actually produced and delivered. So in this case, you see a wall that's been produced by the Amico head wall company. We're working with them right now on a project in North Carolina. It's a 1.1 million square foot hospital, and they're in the process of developing 500 of these units. So the approach here is to redirect that work to points of care around the United States. And as we've talked with Amico about their production velocity, we know that they could do an initial production rate of 100 of these units per week, and they could scale that up to 300 to 500 per week by May 1st. Then we think about how each of these units is loaded onto a pallet, 7 per pallet, and it can be loaded into a shipping container, 56 per shipping container, and driven directly to each site, and how that site then becomes a mobile care space and can be delivered precisely to the point of greatest need and moved from one hotspot to another. The last thing we talk about in this deck is long-term repurposing opportunities for all of these prefabricated components. Here you see the head wall unit, and the idea is that it could be sterilized and repurposed for permanent construction after the surge. Essentially, we were designing this in the first place for permanent construction, so it's going to work well for permanent construction farther down the road. The other option is to stockpile it for the next mass casualty event. And always when we're designing these, we're thinking about it as a smart chassis, this motherboard approach, which is plug and play junction bays for connecting new technology. That means that this head wall component is acuity adaptable. It can begin with med-surg acuity and scale up over time to ICU level acuity with minimally disruptive system upgrades. And here we show the way that new technology can be loaded into this frame over time. Each of the expansion bays is built into this so that you can add new power and data boxes, new medical gas connections, even new human interface control systems and computational technology. So that's where we are right now. This has been a major effort in our firm. We've pulled together the expertise of architects, medical planners, and clinicians, and it's really been all hands on deck. We hope that this material will be helpful in the weeks to come.